Thanks everyone for coming, particularly in the run-up to the exam season. This is a fantastic turnout and it's a testament to Toby. On behalf of the Centre for the Study of Existential Risk, we're delighted to invite Toby Ord to speak to us today. Introducing Toby is something of an exercise in humility in that, well, to say that he's accomplished more at this stage of his career than most people do in a lifetime is something of an understatement. On the one hand, there's his academics. He's made important contributions to a range of fields, including theoretical and practical ethics, population ethics, the impacts of future technology, and high-impact, low-probability risks. He has a background in both computer science and analytic philosophy, which means that he's been an important contributor to the recent discussions over the long-term impacts of artificial intelligence. But he's also been very focused on taking his research and applying it to important real-world problems and policy. So he is an advisor to the World Health Organization on health economics. He's been providing guidance to the UK government in various ways. He was the co-author of a chapter on existential risk for the Chief Scientific Advisor's annual report last year, and a co-author of a report on unprecedented technological risks that went to the Cabinet last year. He has also contributed to the methodology of the National Risk Register. But perhaps his biggest contribution has been in philanthropy. In 2009, he launched an organisation called Giving What We Can. Can I just get a sense, how many Giving What We Can members are in the audience today? A whole lot of you. So that says something. So Giving What We Can is now an international community of people who are focused on giving away 10% or more of their lifetime earnings to the most effective charities, whatever they may be, as decided by the evidence. Toby himself gives away considerably more than that. Based on their website today, Giving What We Can is on the threshold of hitting $400 million in lifetime pledges, which is a remarkable accomplishment in just 5 years, and is growing faster than ever. And it's a central part of the effective altruism movement. Now, this is a very broad range of things, but what brings it all together is Toby's underlying focus on the big picture questions, the global priorities that deserve the most of our attention going forward. Now, one of these is existential risk, and it's been an intellectual pillar of Toby's work for the last couple of years, and what he'll be speaking to us about today. Today he'll talk to us about why it might be our own actions and the fruits of our own progress as a civilization that present the greatest threat to us and to our future potential. And that this, therefore, is the challenge that most deserves our attention and our actions. Thank you very much.
Hi. The title of this talk, Will We Cause Our Own Extinction? I will attempt to answer that question. It won't just be a dodge, but I'm not entirely sure, and it will depend on, for example, when our extinction happens. And in particular, what I'll be trying to look at is whether it will be caused, more likely to be caused by anthropogenic extinction risks, so man-made, causing our own extinction, or by natural extinction risks, and trying to compare the relative likelihoods of these different categories. So human extinction, somewhat needless to say, is one of the worst things that could possibly happen. But surprisingly, given that it is one of the worst things that could possibly happen, it has very little serious academic study. There is a reasonable amount of study on some particular extinction risks. Very little study across the board, though. A colleague of mine at the Future of Humanity Institute at Oxford, Nick Bostrom, looked into this a bit and found that there are more papers published on dung beetles than there are on human extinction. And in fact, just in case you think, well, dung beetles are a very important part of biology, and maybe there's more papers, academic papers, published on Star Trek than on human extinction. So something's a bit funny there. And there's actually a lot of things that you could say about human extinction. It's not all that likely. A lot of the things that we study are things that are at least somewhat likely to happen in the next few years, maybe the next couple of election cycles or something like that. It's not that likely we'll go extinct in the next 10 years, but it would be useful if people could put some bounds or at least some good estimates as to what the chance of human extinction would be over the next century, say. So I think thinking about the likelihood of extinction risks is one category of research that would be useful to have more of. Another is trying to identify and categorize possible causes of extinction and trying to find out more about each of those causes. For example, more about asteroids and comet impacts, or more about nuclear war. And also trying to think about the best preventative measures. This talk will be mainly on likelihood. And I'm happy to report that, that this is changing. With CSER being set up here in Cambridge, the Future of Humanity Institute at Oxford, the Future of Life Institute at MIT, and the Global Catastrophic Risk Institute, and also just a range of recent papers and books that have been coming out on this. It's very much, though, a lot of the research has happened over the last 10 years or so and is really just getting started. What I want to do is to compare the relative likelihoods of natural extinction versus anthropogenic extinction. I'm focusing on extinction via a catastrophic event. Extinction doesn't have to mean that. It could be the slow dwindling of the population, perhaps because a species is being outcompeted by another species and slowly moves to extinction, or something like that. But I'm going to be, some of the arguments I'm saying will actually capture all-cause extinction. But my main focus is on catastrophic extinction, and I'm thinking about this over the next few centuries. We'll get to that right at the end, the limitations of that. As it happens, if I'm asking the question, will we cause our own extinction, and I think it's not that likely that we'll go extinct in the next few centuries, then maybe my argument about which one's more likely in the next few centuries is somewhat moot, if there are going to be many more centuries to come, and if that's when it was going to happen. But we'll get to that later. And I'm going to measure it. There's going to be a lot of comparisons of different risks here. And the unit I'll use is the percentage chance of extinction per century. And I'm going to, argue that anthropogenic risks are more likely. So let's start with the natural risks. So these have, the most solid evidence of extinction risk. The potential extinction from anthropogenic risks that we'll come to later has a lot less proof by prior examples. Whereas with natural risks, we have had many large asteroid and comet impacts, for example. These types of impact or events cause global cooling and plant death on a massive scale. So that's how they kill. So generally by blocking sunlight through the dust or ash that's produced, and then that leading to the vegetation dying, which then leads to the animals dying. And we know that asteroids and comets have caused, well, at least serious damage. There is some doubt about this stuff still, but a lot of people think that such an event caused the KT mass extinction, which is the Cretaceous Tertiary extinction, which is where the dinosaurs were wiped out 65 million years ago. Another type of big natural risk is super eruptions. So there are various volcanoes which are called supervolcanoes, which are much larger than regular ones, and would I think it's because they release a lot of sulfur dioxide, actually, that causes this. I'm not entirely sure of the causal mechanism. But again, they cause a lot of global cooling and plant death. So perhaps that is the likely way things go with natural risks. And they're thought to have caused several mass extinctions. And this is out of a number of 5 mass extinctions. So several is going quite well. Now, there are various ways you could try to bound the natural risk. So we could try to quantify each natural risk. And I think this would be very difficult. I don't really know that it would be possible. But if one could try to go through each of these risk categories. So you could say, okay, what about asteroids or comets or supervolcanoes or pandemics, or looking through lots of different forms of risk, taking each one, trying to find out a lot more about the subject matter, and then trying to work out, and this is the really tricky bit, the chance that it would cause the extinction of humanity. So that would be very difficult. I'm going to show you how to do a shortcut so that you don't actually need to know about what the different extinction risks are. And there's a lot of advantages of that. One is that it's actually much more tractable to get results. And you'll see that it's not that hard to actually bound the natural extinction risk if you use this technique. And it has this nice advantage that if you tried to go through them all one by one, then you could easily leave out a very important extinction risk that you weren't aware of, whereas the technique I'm trying to use will capture them all at once, and so it's guaranteed to not have that problem. And what I'm going to look at in particular in this natural risk section is 3 different approaches to estimating the natural extinction risk. One is by looking at how long humanity has survived so far. The second one is looking at similar species and their survival times. And the third one is looking at the mass extinctions. So the mass extinction record, how long is it between mass extinctions? So here's a sketch of an argument. Okay. Homo sapiens, our species, has survived for 2,000 centuries so far. During that time, it was vulnerable to all of these natural risks. So it's unlikely we would go extinct from these risks in the next century. Since we survived 2,000 of them, it seems, one couldn't think there's a 50% chance that we'll go extinct in the next century from these things without some further argument. So we can make this a bit more precise. So what we're trying to work out here is the probability of extinction per century. A naive type of calculation might be to say that it is 1 in 2,000. If there are 2,000 centuries, then the chance of going extinct next century might be 1 in 2,000. Certainly a number that would occur to one. However, that would be the correct type of answer if we had gone extinct once in 2,000 centuries. We've gone extinct 0 times in 2,000 centuries, so 1 in 2,000 isn't quite the right thing. And 0 in 2000 also wouldn't be quite the right thing. It's fairly obvious in that case that you can't say the chance is 0 just because it's never happened so far. So you need some slightly more powerful ways of thinking about this. But you can see that the intuitive answer should be less than 1 in 2,000, since that's kind of what you'd expect if it had gone extinct once in 2,000 centuries. So what you can do here is use Bayesian statistics, particularly something called Laplace's law of succession, where you try to work out the probability of an event which is so far unprecedented. And the way you do this is you start off with a prior probability distribution, and then you update that based on the evidence. I won't go into all the details of what Bayesian priors are and so forth, but for those of you who already know, you should be able to see what I'm doing. So one way to do that, and the way that Laplace originally did it when he tried to calculate things with his law, is to use a uniform or flat prior. So the idea there is to say, at the start, you assume that the probability of the event occurring could be anything between 0 and 1. And it has as much chance of being between 0 and 0.1 as it does between 0.1 and 0.2 or 0.2 and 0.3, and so forth. So it's just, you can see here that it's just a flat distribution. If you do that and you crunch the numbers and you say, suppose that the actual probability per century before I know anything, I think it's equally likely to be anywhere, and then I notice that it hasn't happened 2,000 times in a row, you get the result 1 in 2002, which is indeed less than 1 in 2000, but not much less. I think a more sensible way of using the Bayesian statistics is to use a Jeffreys prior, which is on the right there. And the Jeffreys prior has the probability, it's more likely for things to be near 0 and 1 than in some other place. And I think you can intuitively reflect upon that if you think, if you just think of some event that someone tells you about and you know nothing about the subject matter, Maybe they ask you about what's the chance that a certain Pokemon will beat another Pokemon or something, and you have no idea about this the subject matter. It's more likely the probability is between, say, 0% and 1% than it is between 37% and 38%. They just turn out to be quite a lot of things which are very unlikely or very likely. These probabilities get clustered towards 0 and 1. And the Jeffreys prior is a mathematical way of interpreting this. It's also called a maximum entropy prior. So if you use this Jeffreys prior, you get the number 1 in 4002. And you're not going to have to just take my word for this, as we'll see some more ways of looking at these things. This is just one of them. But I think that the Jeffreys prior is a pretty reasonable way of answering this question, and would give you the idea of extinction at about 1 in 4002 per century from natural causes. Okay, but another way to do this, which is perhaps more sensible, certainly used commonly in science, is to use p-values. And so the idea here, here's an intuitive argument. If the chance of extinction per century were 1%, then we would have survived 2,099% chances in a row. Each one we're quite likely to get through, but surviving 2,000 of them sounds fairly unlikely. And if you crunch the numbers on how unlikely it is, you'd find that there would only be a 0.000002% chance of getting through that many centuries in a row. So that seems to be an argument that the chance per century is lower than 1%. And you can kind of formalize this. I've got a table here with some different p-values. So the way that you read this table is you say, if you look at the bottom row first, I guess, and you say, basically that if the probability were greater than 0.03%, then there would have been a 0.5 chance of going extinct by now, p 0.5. If the probability had been per century had been greater than 0.1%, then there would have only been a 0.05 chance of getting to where we are now. So only a 5% chance we would have made it through. And the third one is with a p-value of 0.01. Commonly, for some reason, in scientific studies, they tend to use 0.05 for no apparent reason. But you can see what the relevant value would give you here. So one way of roughly understanding this that isn't quite right is to say that third column says that we're 99% confident that the probability of extinction per century is less than 0.2%. That's not quite right. A better way to say it is that if it were more than 0.2%, then a 1 in 100 event has occurred. We got exceptionally lucky in terms of surviving this far. Now, in some cases, you'd have good reason to believe, perhaps, that a 1 in 100 event did occur. Suppose you looked at every other species' lifespan, and you found that all other species only lived, for 100 centuries, and no other species lived longer than 100 centuries or something like that. You might think, well, it sounds like the probability you'd expect to be around about 1% per century. And that I guess we did get spectacularly lucky. It's perhaps more likely that we got spectacularly lucky than that we're a fluke species. So in some cases, you might think that that basically for the probability per century to be less than 0.2% would be even more unlikely for some other reason than that a 1 in 100 event occurred. And so it is possible in some cases, if you have some outside evidence, to push back against these p-values. And that's true when they come up in the scientific literature generally. But as we'll see later, the other species' lifespans are actually quite a lot longer than 100 centuries, and there doesn't seem to be anything that does push back on this. And I think that they stand up reasonably well. It looks like it is very unlikely that the probability of extinction from natural causes is greater than 0.2%. There are some assumptions behind all of this, which I'll get to in a second as well. So, a further question that we could ask is, what is humanity? I was using Homo sapiens here, but you could use some other definitions as well. I think most people really include Homo sapiens, so all members of the species Homo sapiens who ever lived, as part of humanity. But you could use broader definitions. I'm not sure many people would use narrower definitions. But if you thought that the Neanderthals are quite similar to us in various ways, and indeed there are a lot of commonalities, you could look back far enough in time to when the last common ancestor between humans and Neanderthals, which will take you back 5,000 centuries. You could look as far back as there have been tool-using hominids. Our ancestors who used tools of various forms and made their own tools, I think in particular here. And that would take you back 26,000 centuries. Or you could look at the entire Homo genus, and that will take you back 60,000 centuries. So there's some other definitions you could use. Then I have the numbers here for if you use the naive calculation or the flat prior or the Jeffreys prior. And basically what you'll note is that the number in the top right-hand corner there, 0.02%, is the highest of the numbers. And what I'm really trying to argue in this section, we'll notice this when we get to the anthropogenic risks, but basically is that the natural risks are less than 1% per century. So I'm showing a whole lot of different techniques, and they're all producing values which are going to be less than 1% and generally substantially less than 1%. But they do give us a range of values. But 1% should be I'm showing you enough numbers that you'll probably lose track of what's going on unless you have some kind of anchor point to compare them to and consider how close they are to 1%. Now, below that, I have different p-values using this p-value approach for the different definitions of what humanity is. And if we go to the most extreme right-hand column, I'm now looking at p of 0.001. So there'd have to be a 1 in 1,000 event occurred for these numbers to be wrong. And even then, you could see that, and even on the most conservative definition of humanity, just as Homo sapiens, that with a p-value of 0.001, it's less than 1/3% per century as the risk. Okay, so that was trying to look at humanity that we've survived for a very long time and hadn't gone extinct, and to try to get some numbers from that. Now let's look at related species, which is another way you can try to bound all of the natural risks put together. So we can look at some other species which are extinct, and then we don't have the problem of having a 0 in the numerator when we're trying to do some of our calculations. So you could just do those naive calculations, which I've got on the right-hand side here, for different species, Neanderthals and various other hominids. They again give you some pretty low numbers. You could also look at, you can see the second last row there is for the average mammal, which lasts between 10,000 and 20,000 centuries. If you look at the entire fossil record of different species of all different types, vertebrates, invertebrates, and that are at least fossilized. Obviously, it's hard to get numbers for the ones that don't fossilize. And you get, again, some very low numbers for risk per century. In general, a century is a pretty small time on a geological time scale, and it's pretty unusual for species to go extinct within any given century. You could also run those things with more sensible techniques, such as those I mentioned with the flat prior or the Jeffreys prior, or using p-values, and you get numbers which are very similar to the table of numbers you just saw. This is not that surprising because the number of centuries I have in these different bits are very similar to the numbers of centuries that I was looking at before for different definitions of humanity. And you crunch the numbers through and you get numbers which are very similar to these ones and to the ones you just saw. Okay, so a third way of doing this is to look at the mass extinction record. So humans are so widely spread and so very capable at defending ourselves and adapting that it's plausible that it might require something at the level of a mass extinction in order to wipe us out. That sounds pretty plausible to me. And if so, then people typically talk of the big 5 mass extinctions. I should say there's a bit of pushback on that recently, that it's hard to actually come up with a definition such that only 5 count as mass extinctions, even though that's what's commonly talked about. There may be more, which But if you just use the big five, you get 5 mass extinctions in 540 million years, which is about 1 per million centuries. So if you just do a simple calculation on that, you get an implicit probability of 0.001% per century. And this is quite a bit lower than the other methods. So if it would really require mass extinction to wipe us out, then we're quite a bit safer from natural risks than the other things would have said. And this would remain the case unless you counted more than 100 things as mass extinctions. And while there's some debate about whether there's only 5, people aren't normally counting 100 things as mass extinctions. And if you're thinking the kind of thing that killed the dinosaurs, that's the kind of thing that would be needed in order to kill us, then you're looking at once every 100 million years or every million centuries. And so the expected amount of time we could survive from now would be about 1 million centuries before something like that happened. So that would be pretty good news for us if we managed to do that. I imagine a lot of you would be not that optimistic that we would get through 1 million centuries of risks caused by ourselves before we got wiped out by such a thing. There were various assumptions behind the 3 different types of argument that I just showed you. And I should flag they're very rough estimates. Maybe I should have said that at the start to avoid people worrying too much about that. That's why I only use 1 significant figure in each of them. I'm trying to just use them to establish a rough upper bound. So basically to say, here are some back of the envelope ways of trying to calculate and bound this, using a few different techniques, getting relatively convergent answers, and making it so that if someone wanted to say, oh, I think the natural extinction rate for humanity is more than 1% per century, the burden of proof would really be on them to see why on earth they could come up with something like that, given that it just seems like it's very hard to explain how we could survive 2,000 centuries if you think we only survive 100 centuries on average, and so forth. And they also assumed a constant risk per century, which is a bit more controversial. Although actually all I really need there is that the risk isn't increasing. If the risk were decreasing over time, then the risk in the next century would be lower than these numbers would make it look if I've been assuming a constant risk. So the real assumption here that I'm relying on is that the risk of natural extinction isn't increasing. And I think in most cases that's a pretty good assumption because we've got a whole lot of, we've spread to many different niches, we've spread to many different continents, where generally looks like we're much more robust than a typical species. However, there's potentially one big counterexample, which is pandemics, including, in some sense, naturally caused pandemics. So we're not talking about genetic engineering here. And I think of pandemics as being a kind of in an intermediate category between natural risks and anthropogenic risks, as they arise from natural origins, but they're very much exacerbated by human society and also human technology. So the fact that we can travel, and people do travel, many people travel halfway around the world every day, joining points on opposite sides of the world within a few hours in terms of sharing their germs with each other and spreading things around. We've done a very good job of making the whole thing mix very thoroughly, very regularly. This can cause problems. We also raise livestock very intensively, and in some cases with related animals, which we know give us diseases. Think of bird flu, and so there are a whole lot of things going on there where I don't expect I don't feel safe in thinking that the natural historical record for pandemics is that the risk is necessarily decreasing. It feels like it could well be increasing. So that's one where I want to bracket that. And when I talk about natural risks for the rest of this, don't include pandemics. So in summary for this section, all of the estimates we have here for natural risks give risks of less than 1%. The highest one was an upper bound of 0.3%, and that was an upper bound, and would says that you'd have to have a 1 in 1,000 event to occur to even get to that point. And that involved the narrowest definition of humanity and the most extreme confidence. And most of the risks ranged from 0.002% to 0.1% per century. So it thus seems difficult from what we've seen so far to assume a natural risk of greater than about 1/10%, and untenable to assume greater than 1%. At least so I would claim. Maybe someone has some good argument for why, why one of these assumptions fails or something like that. But that's what it looks like to me. Okay, so let's move on and look at some anthropogenic risks. And you'll be not that surprised to hear that these are much more difficult to estimate. And basically, I can't use the trick that I used before. Here's what happens if you try to use the trick. So in this case, suppose you try to assume we had certain small amounts of technology from the Neolithic period. So if you say, well, what about the types of anthropogenic risks which we could have caused from the Neolithic period onwards? You might think that there aren't any. It's actually not totally clear. One type of risk that we face are various forms of government risks, government democides, where the governments kill their own people, as an example of a risk. And there, many millions of people were killed in the 20th century from that. I think around a similar amount as were killed by war, were killed by governments killing their own people. Maybe it could have been the case that once we developed societies and had an agricultural revolution, that we're in the situation where we could start doing certain types of social risks, which would count as man-made, but doesn't sound all that likely. That would give you 100 centuries to work with, which would actually let you do a little bit of a calculation, getting numbers like 0.5% or less than 3%. However, it's not really what we're thinking about with the anthropogenic risks. It certainly doesn't include most of them. There's no nuclear weapons there or anything. It's not telling us about a lot of these things. If you try to get a more close, understanding of a technological risk of some sort, say looking at time since the Industrial Revolution, this gives you 2.5 centuries, which is not enough time to get sensible numbers. The Jeffreys prior gives us 20% at that point of extinction risk per century, but it's a very rubbery number because it's based on so few data points. To have a p-value of 0.05, it says you'd need it. All of that says is that the risk is less than 70%, but it doesn't say where less than 70%. And less than 70% includes a lot of risks, right? It includes 1 in a billion per century, and it includes 50% per century. So it's just a really uninformative number. And if you look at the time since nuclear weapons, it's even more like that. I think that there might be some things you could do with those numbers. For example, if you look at how long we've survived since nuclear weapons, that at least gives us some indication that one can survive 70 years with nuclear weapons, which wasn't obvious at the time. Some people, I think, thought that we were doomed to much shorter time scale than that. And you might be able to do some kind of analysis there. But I'm not going to try to do that tonight. So yes, there's not enough data to sensibly use the Bayesian approach, and the p-values approach just gives us very weak upper bounds. And also the upper bounds wouldn't help us compare against the natural risks because we had upper bounds for them as well. What I want here is more like a lower bound, to bound it away from the other probabilities in order to get a result. We could look at anthropogenic extinction of other species, which we do all the time. Humanity is very good at making species go extinct. Sadly, but that doesn't look like it's particularly relevant. I can't see how to get any kind of useful number out of that. So let's look at 3 different examples of anthropogenic risks in order to think a little bit more and try to get a bit of a feeling for what the probability is. You can see that this is not going to be producing really nice, crisp numbers, I'm afraid. What I'm trying to do is to suggest that once you look at the cases, it's pretty difficult to put numbers which are as low as the numbers that we were putting for the natural risks. But I'm not going to be able to make a very tight argument about that. So The total energy of the current nuclear arsenals, which were reduced from their peak, is about 80,000 times the energy of the Hiroshima bomb. There's a lot of energy there, but the risk isn't that everyone will get exploded by nuclear bombs. The risk is that the cities will get exploded. The cities contain a lot of flammable materials. The materials in the cities will burn. A lot of people will be destroyed if there was an all-out nuclear exchange in that initial exchange. But that's not the extinction worry, because even though in fact, we've just passed 50% urbanization of the world, so 50% of the world's population live in cities now. But that still leaves 50% quite widely dispersed in rural areas. And they're not going to be destroyed in blast by nuclear exchange. However, the burning of the cities produces soot, which rises up into the atmosphere. Quite a lot of it gets higher than the clouds and doesn't come back down again in rainfall very quickly. And so it stays around, blocks out a lot of sunlight, leads to cooling and health failure. There's surprisingly little research on nuclear winter. There are, a few government studies and a few papers, and there's some recent research, which I'll show you in a second. It may not lead directly to human extinction. It's not clear that a nuclear winter would be enough to make our species extinct. We might be able to get through it, at least some people. It would be very bleak. It certainly would be a incredibly bad global catastrophic risk, but it might not be extinction. However, it might be. We just don't really know that much about it. And it also would leave us less able to recover from other things that would happen if there was also a big pandemic in, say, the 100 or 2 years after. That could be something that could be difficult to recover from. It would be vulnerable to other types of threats. We also may never rebuild civilization in the same way that we have it now. You might think that'd be good in some ways. There are perhaps some problems we made this time around, and maybe we wouldn't make them. But by the same token, there could be some other things, like general Enlightenment values might not come back the second time round. It could be more that it's built up in a despotic kind of style, and democracy doesn't flourish again. It's really quite unclear. It doesn't look good. I would think that if there was an all-out nuclear exchange, that the chance of human extinction, from what I've seen of this, would be less than half, probably quite a lot less than half, but still be looking very bad. I'm not, with this section, I'm really not trying to actually just make you believe the same numbers that I believe, rather just to share some of the information that I've thought about in this. Actually, here is, I said there was a recent study on this. This is their model of soot spread. The original detonation is, I think, on the 14th of May, so this is 10 days later. And it's somewhat good news for the Southern Hemisphere, but this is just within the first month, and I think that I think a lot of it does eventually end up in the Southern Hemisphere as well. It's not good. And you might think that at least we didn't have an all-out nuclear war, but we did get close to it on quite a number of occasions. And you might think that there was this great mutually assured destruction policy, which the game theory was all sorted out by people at RAND, and probably no one's thinking that, but people indeed thought about the game theory and worked out this approach such that they build the arsenals large enough, then it would be insane for the other people to launch, which is true. However, various insane things did happen, and this type of brinkmanship can make it worse if there are insane things happening. So here are an example of some of the things that did happen. In '62, there was the Cuban Missile Crisis, during which there were a number of really quite amazing incidents. Kennedy put the odds of nuclear war at that time between a third and a half. So he was, and he should know, since he would have been one of the people starting it. And they were very worried. There's a fantastic documentary that's been made about this, where Castro had talked quite a bit. It mainly features Robert McNamara, who's describing interactions with Castro. And there's a part where McNamara is explaining this meeting they had, I think in the 90s, long after the missile crisis. And it was basically a debrief on the whole thing. And McNamara asked Castro, I think a few questions. One was, did they have nuclear missiles that were under Cuban control? If they did, would they have launched them against the US? And if they had launched them against the US, did they know what the consequences of that would be? And Castro answered that they did not have any that were under Cuban control, although they tried to argue with the Russians to get them under Cuban control. That if they had them, then at the height of the conflict, they would have launched them to the south of the US, which is as far as they could reach, I think. And that the consequence of that would have been the destruction of Cuba. So that was Castro's view, according to Castro, was that he would have caused a nuclear exchange if he'd had the ability to do so at the time. It's very sobering. That's called Fog of War, so I encourage people to have a look at that. In '79, there was the training tape incident where basically a training computer program that went through a drill as if there was a nuclear war. Was interpreted as being real. So it's like when the fire alarm goes off and you're not sure if it's a drill or not. But 4 different nuclear command centers weren't informed that there was going to be a drill and thought that there was a real Russian first strike at the time, and mobilized quite far towards retaliating. In 1980, there was the faulty computer chip incident, which caused displays to show launched enemy nuclear missiles, and so all the people in the command centers had a whole enemy attack appearing on their screens, but didn't launch back. In '83, there was the Alle Archer incident. That was a NATO exercise, military exercise in Europe, which was interpreted as being a real attack by the USSR, who didn't know that there was a test. And again, they escalated quite far. In '83, there was the autumn equinox incident, where sun on clouds was reflecting in the stratosphere, I think. Basically, they have the systems to detect nuclear launches. The way they do it is they get a satellite. If this is the Earth, they get a satellite very far from the Earth on a highly elliptical orbit, such that it spends most of its time out here, because that's the way elliptical orbits work. They're very slow out here and very fast in there. And when it's out here, it looks at this piece of the sky above the US to see whether there's any flares from rockets. And it sees bright light if there is a flare. And it saw a whole lot of bright light and detected launches. They appeared on the command screens. The USSR didn't do a counterstrike. That's where Petrov, a Russian commander, didn't escalate. He chose not to because he thought that it would be too implausible. I think what they saw was that there was a small first strike, and they thought just the US wouldn't do that, so we're just going to ignore it. And I won't tell my superiors about it. And he didn't do very well in his career after that, because that wasn't the kind of attitude that they wanted. The whole idea of the mutually assured destruction was that, our people are crazy enough that they're going to push the button. They needed to get that locked in order to make the game theory work. And then after the Cold War, there have still been pretty serious incidents. You might think that we're safe now. In '95, there was the Norwegian rocket incident, which Norwegian weather rocket was launched actually away from Russia, and somehow the Russians interpreted this as a nuclear strike, and it got as far as opening the 3 Russian nuclear briefcases, with the controls to do the launch, and then got stopped. And even though we're in relative peacetime now, maybe if I'd written this talk a couple of years ago, it's a bit less good again. But tensions could escalate. We could get back into a Cold War type situation, particularly if we're thinking about the risks over a century or several centuries. One would expect it to move back towards a mean. You can also think to yourself about the chance of, would there have been all-out nuclear war if we'd had the Second World War at a time when we had mature nuclear weapons technology? And it looks pretty plausible that there would have been. If we end up in another situation of total war, which we've had, many times, we've got a track record of that, then it doesn't look too good. So it seems to me that there is, quite a reasonable chance of all-out nuclear exchanges, albeit that doesn't equal extinction. There'd still be more steps you'd have to go through, but it'd be very bad. Another example here, the second example, is artificial pandemics. So people engineering their own viruses, probably, although you could do bacteria. There's an increasing ability to genetically engineer pathogens, and with lots of different ways to do this. A nightmare scenario would be something that combined the infectiousness of the common cold with the deadliness of rabies. So I think one person has survived rabies. It had 100% lethality until I think somewhat recently, where someone somehow survived. So maybe it's not as maybe deadliness just slightly more than rabies. And the incubation period of HIV. So if you had something that spread like a cold, but it took a year before anyone showed any symptoms. And once they started to become symptomatic, they had 100% mortality. Then basically almost everyone would be infected before we found out anything about what was going on. Naturally occurring diseases don't combine these three aspects, but they do all occur separately, and one could genetically engineer these types of things. I'm not sure exactly how difficult it is to do that. I don't really want people, I'm not sure how much research we want on finding out, but there are definitely some scary looking possibilities to do with artificial pandemics. You might think, who on earth would want to do that? Which is a pretty good question. Relatively few people would want to do that. The Aum Shinriko cult that did the sarin bombings in Tokyo, they wanted to do stuff like this. So you do occasionally, and they were getting scientists, they had at least one scientist on their team to develop the nerve gas that they used. So there are groups who have access to scientists who do occasionally want to kill everyone. But this is not just a kind of terrorism type thing. It's a very particular type of it that would lead to wanting to do this type of thing. However, unfortunately, these technologies are becoming more and more accessible. At the moment, the accessibility probably just looks like mainly a good thing, because instead of needing, a PhD and 20 years of experience in a lab of people or something in order to engineer your own viruses, it's moving down. You don't even need a PhD. There's in terms of synthetic biology, there's a very prominent competition now for school children doing synthetic biology. So that's a fairly radical forms of genetic engineering. Not on viruses, I don't think, but so it's becoming more and more accessible. And you can see that once, if we've got this idea of, who would want to do this? Well, very few people. It's a tiny fraction of people want to do it. But how accessible is it? Well, it's getting more and more and more accessible. And as it gets accessible enough, then even if there's very few people who want to do it, some of them will have access to it, and things like this will happen. So I don't think it's all that scary next year or the year after. But if we look over the next 100 years, I think this type of thing is pretty scary unless we work out as a society how to actually stop it. And my third example of a anthropogenic risk is artificial intelligence. So we currently have many narrow AI systems, for example, chess-playing computers, which are smarter than us at particular things, but very narrow things. Less than 1% of what we do is chess, I hope. So they look at very narrow topics and are very good at them, or multiplication would be a more obvious example. But they're not good at general intelligence. But if we were to develop machines which had general intelligence greater than that of humans, which could do kind of all the tasks that we could do as well as we could, or even just half the tasks we can do, or something approaching that, then that would be a momentous development, possibly, possibly the biggest news on the Earth since the advent of Homo sapiens. And I don't mean that to be grandiose for Homo sapiens. I mean, Homo sapiens have been very big news on the Earth, sadly, mainly in a negative way so far in terms of changing things. But we're clearly the most dominant species on the planet. Hence the moves to rename the current era the Anthropocene. And the reason that we're the most dominant species on the planet is not because we're the strongest or the fastest or something like that. There are a very large number of species, and what we are is the smartest, and that's what's let us get there. So if we created something that was smarter than us, we would no longer have that unique position, and seems, you might think at least somewhat plausible, that, that we would also no longer be the dominant species on the planet. This becomes more likely as well when you think very carefully about the difficulties in controlling AI and in aligning its goals with our own goals. There's been a reasonable amount of written on this recently. Some of it's a bit silly in the newspapers. So I'm not talking about a kind of Terminator type situation. But if you program a computer with some kind of goal, say calculating as many digits of pi as possible, just to pick an example of something which is a maximizing goal, but which doesn't have anything about humans directly in it. It feels kind of neutral to humans, just orthogonal. Certainly it's not malevolent towards humans or anything like that. It gives them no intrinsic value at all, no positive value, no negative value. However, if you were very smart, probably people in this room could have worked out that, that if you wanted to calculate a lot of digits of pi, you might want to, say, at least take over the internet with a kind of botnet type attack. And humans wouldn't really like that. If you want to calculate a lot more digits of pi, if you think about the long-term future, maybe you'd want to have all the resources of the planet. If you had all the resources of the galaxy, you'd have even more digits you could calculate. You could actually potentially do very well at this task if you achieved certain things. But those things are not compatible with a flourishing future human civilization. And so you would then be aware that humans didn't like this, and then it would turn out to be an instrumental goal would be to stop the human stopping you from achieving these types of things. So that's the standard type of line of thought here, is that even if you start with something that just feels orthogonal to human interests, there's no malevolence. It turns out that if it involves an insatiable desire for resources, then that's incompatible with long-term flourishing of humanity. So that would lead to an instrumental goal to at least block humans and stop them getting many of the resources. So there's been a lot of thought about this recently. Nick Bostrom has a very good book on this called Superintelligence, looking at some of these scenarios and trying to understand these arguments. There are various attempts people have had to try to work out how could you stop that happening. I mean, maybe the problem is just goals like calculate the digits of pi, and maybe you could have better goals. It's not that easy to get this to work, and there's a flourishing area, though, now of thought about this. And if any young people are interested in, I think that there will be jobs in this in the near future. That is, in trying to understand the risks and trying to work out how to prevent them. And all of this is made worse if development is very sudden. So one example of sudden development that people talk about is an intelligence explosion. I.J. Good came up with this idea quite a long time ago now, and about 50 years, where the idea is that if you had a system which was sufficiently smart that it was smarter than the entire AI research community, then the amount it could improve itself by would be greater, the amount of work it could do on AI research would be greater than the humans. And it could improve itself and make itself better and then make itself better again. And maybe this would lead to a runaway improvement in its own intelligence. There are a couple of questions about the argument. For example, it's compatible with it being asymptoting towards some kind of intelligence. Maybe it gets smarter and then smarter and then smarter and then smarter and smarter and smarter, but never passes some threshold of intelligence. It's not really clear exactly what would happen with the argument, and that's something that we're trying to actually understand a bit better. Are these intelligence explosions actually likely or not? But it's something that's been theorized and would lead potentially to a rapid increase, such that a system that people previously didn't put a whole lot of thought into or worry that it would get out of control rapidly gets out of control. Even just widespread deployment could do this. If you had a system that was as intelligent as a person and could run on a single desktop computer, then if you were to deploy it on, say, everyone's computers, let's even just say 10% of the computers via internet hacking attack, then you would have something which had more intellectual force than, say, the entirety of the US, because it would, if each one is as intellectually powerful as a human, and then you've got more than 300 million of them. So there are even just some really rapid things that could happen in terms of scaling up the hardware. Also, if Moore's law is still going at that point, then the population of them could be doubling every 18 months. So there's some reasons why things could move very quickly in this area, and it could be hard to get things sorted out before the technology develops. So a couple of questions on this one. What's the probability of this arriving this century? If I were to guess about this, I've thought about a reasonable amount, but you don't need to take my word for it. I would think maybe 40% or 50% or something that this century will have things which are smarter than humans. There's certainly been a lot of very good progress recently. Progress had stalled for a while in the 80s and 90s, but it's gone a lot faster recently. But I would be pretty surprised if it didn't happen within the next few centuries. And what's the probability, if it did happen, that we wouldn't survive? I'm not sure. But if you multiply those two things together, you get the existential risk due to this thing. You can see for yourself, if you put numbers on those, to see whether you end up with a ballpark number which is greater than 1% or less than 1%. But for me, it would be greater than 1% just from the AI risk alone. So some people have tried to make estimates of anthropogenic extinction risk. Martin Rees, who we have here in the audience, estimated a 50% chance of anthropogenic extinction over the 20th century. Maybe it's a little bit unfair because 15 years have elapsed, so it would be slightly smaller now or something, but it's something in that ballpark. At a conference that we had in Oxford, launching really the study of global catastrophic risks, there was a survey done with a lot of questions, one of which was about the aggregate amount of existential risk in the, again, before 2100. And the median estimate by the researchers at that conference was 19%, most of which was anthropogenic. We sadly didn't ask for a direct breakdown, but not much of it was natural. You might expect that one to be a bit upwardly biased, perhaps, because the type of people who attend conferences on global catastrophic risk might be the type of people who think that it's more likely. Others, they'll be selected for that to some degree. Obviously, if you think it's really unlikely, you wouldn't turn up. So there's at least some selection pressure there. I don't think it's an unreasonable guess, though, myself. Although maybe I'm also selected for that, so you bear that in mind. The Stern Review, a reasonably sober document produced in this country, by Lord Stern, had a extinction rate built into it of 0.1% per year, which ends up being approximately 10% per century, as the Treasury's view on extinction rate, which I thought was quite interesting. It's actually really quite high. It's a bit surprisingly high, given that the Treasury don't actually take extinction all that seriously. They don't spend much money on avoiding it, but they put it in here as 0.1% per year. I hope that they will, in the future, at least mesh those things together a bit better. But there are a few estimates that I've found. There aren't many people who have estimates on this. Compared to natural risks, all of these are more than 10 times my conservative 1% bound, or more than 100 times my more realistic 0.1% bound. So you could ask here, would it be plausible to have estimates of this anthropogenic risk below 0.1%? If not, then it seems that we've now got a pretty nice argument that the anthropogenic ones are more likely than the natural ones. One way of paraphrasing that question is, would we expect to be able to get through 1,000 centuries like this one before we went extinct from from anthropogenic causes. I would like to think that we could, but sadly I'm not that optimistic. But you can kind of try to come up with your own judgments. So a couple of points here to make before I finish. One is about limitations of this argument. So one is that, as I said earlier, the bounds for natural risks don't apply to pandemics. Human social systems and technology exacerbate them, so the risk might be increasing over time. And so they're in this intermediate category. So I'm setting them aside, which is a bit of a dodge because the talk did say natural versus anthropogenic, so at least you can bear that in mind. Also, the arguments are based on averages, the argument would fail if we happen to know that we're at a time with much higher natural risks. For example, if we spotted a 10-kilometre asteroid on a collision course with the Earth, you couldn't just say, well, it's okay because of this argument. Then you would know you're in a time of unusually high risk. Now, I don't know of any serious examples like that at the moment to do with natural risks. There might be some serious examples with anthropogenic risks as to why we're in an unusually risky time, but it seems like not with the natural risks. And then a very natural question that comes up is, does this mean we should focus on anthropogenic risks if we're worried about extinction rather than focusing on natural risks? You might think that obviously the answer is yes because of this talk, but it's actually not that obvious. So being more probable doesn't guarantee it's more tractable. What we really care about is the absolute risk reduction per unit effort. So for example, if you spend your career on it, if you spend your career on natural risks, will you reduce the extinction risk by more percentage points than if you spend your career on anthropogenic risks or not? That's what you really want to know. And it's possible to have something where there's a higher risk, but it's actually very hard to do anything about it. Now, I think it's that there's at least a fairly natural consideration, though, that in general, more probable risks, it's easier to do more about them. So if you imagine how hard it would be to reduce a 5% risk of extinction to a 4.9% risk of extinction versus reducing a 0.2% risk to a 0.1% risk, so halving it. My guess is it would be easier to do the first thing, there's a kind of diminishing marginal returns type thing that can kick in when you're trying to get rid of the last amount of risk, and that can be quite difficult. So that could be some reason, therefore, why it is that the bigger risk does mean it's more tractable. It certainly means there's more to do, like if you have a larger margin. If you ask what can we do with 10,000 careers, working on this stuff, well, with the natural risk, the most we could do is get it from whatever it is now to 0, and that's not all that much. I think actually we could probably do more on the anthropogenic risk at a larger margin like that as well. So I guess I didn't put that in here, but that's another point. Also, we know that anthropogenic risks have some tractability, as opposed to the natural risks, where it's a bit less clear. It's not that clear what to do about a supervolcanic eruption. But with nuclear war, we know how to stop nuclear war if we all were willing to do the policy, which is you just don't launch the nuclear weapons. If no one launched them, there'd be no nuclear war. So at least we know that if you could get 195 people, the leaders of the different countries, or maybe I think there's only about 20 nuclear powers, so if you just get those 20 people to not launch nuclear weapons, then you don't have nuclear wars. That's a lot harder to do than just saying it. But at least we know that it is somewhat tractable. It's a social coordination, political coordination problem that one could work on, as well as potentially technical issues. The same can't be said for most natural risks. So what we want to think about is which is more tractable on a kind of margin, probably of like if you had an extra research team or an extra $1 million of funding or an extra motivated government trying to think more seriously about this, which one would they be better off focusing on? And my feeling is the anthropogenic risks. I can't really see much good reason why the natural risks would win that. Oh, sorry. I managed to skip through my conclusions there. But basically, I remember them. The conclusions are that we looked at the natural risks. I said that it really seems that there's pretty good arguments that they're bounded by 1%. They couldn't be more than 1% per century, or we wouldn't be able to explain why we've been here so long. And it's actually pretty hard to see why they'd be more than about 1/3%. The anthropogenic risks, though, look like they'd be quite a lot larger than that, probably larger than 1%. I'm not quite sure how you'd come to the judgment they're less than that per century, but I don't want to just tell you what to think on that. So therefore, if we were to go extinct in the next few centuries, it seems that we have reason to think that we would go extinct via the anthropogenic risks. The argument, though, doesn't actually capture the full long term. If we go extinct in 10 centuries, 100 centuries' time, maybe by that point we will have got the anthropogenic risks very small as well. And we can talk about that a bit in discussion as to what are the prospects of doing that. Thank you.
Thank you, Toby, for that fascinating talk. We've now got about 20-25 minutes or so for discussion. I'll make a cue. Please put your hand up if you'd like to ask a question. Alexander first, then Alice.
So, thanks for the talk. You started by saying that it would be a pretty bad thing if we all went extinct. That's a pretty sensible view to start out with, but I'm just wondering if someone were to press you like happened, what are the theoretical underpinnings for it? I mean, there is the view that badness and goodness only pertains to for people. So something can be bad for somebody or good for somebody. But once everyone's gone, there's only there for something to be bad for. So I wonder, what's the ethical theory? What would you say?
So, I mean, I guess there's a few different angles you can take on this. So there are several different arguments you could run to say that it would be good if we went extinct. Most of those arguments have the conclusion that it's also good when individuals die. So if you have an environmentalist argument about this, that the Earth would be better without humans, it also tends to imply it'd be better with one fewer human as well. And that otherwise there's some kind of discontinuity in the argument that's quite difficult to explain. And that therefore, the NHS is a much worse healthcare system than the US healthcare system because it saves more lives, and you end up with a whole lot of really perverse kind of conclusions coming out and so on, which don't fit how anyone actually thinks about their lives or how we act in any normal day-to-day things. So I'd be quite suspicious of reasoning that was so at odds with everything we think about whether murderers should go to jail or be given medals or something. The view that if no one were still around, that at least avoids that problem. I guess it's interesting, I've never heard it taken seriously in philosophy as a view. So I don't know what the standard kind of arguments are about it. It certainly doesn't seem very plausible to me as a view. One thing that I think, though, is quite useful to say about this, and about perhaps a wider selection as well. So it seems, so suppose we give some weight to that idea. We think there's some chance that it wouldn't matter if humans went extinct, but there's also a pretty reasonable chance that it would matter. And if it did matter, it seems like it would matter a great deal. Because not only would there be, in these catastrophic cases, would there be 7 billion deaths, but there would also be no more kind of art and culture and other things that we value going forward. And that there are potentially thousands more generations, all of which would be extinguished as well of humanity. So it seems like it'd be very bad, if it is bad at all. And so one want to hedge against this a bit. And it seems that one of the areas that I've looked at quite a bit is moral uncertainty, which is what to do if you're uncertain about ethical theories. I think in this type of case it's a good example of it, where you'd want to do some hedging because you have some credence in a view which says it would be incredibly bad and some credence in a view that says, oh, maybe it's not that bad. And you probably want to at least put some weight on it being very bad.
Just for the record, I do agree.
That's a relief.
My question was very similar to that one, so it's probably already covered, but it was more about why should we care rather than if there's no one here, then no one will care. But kind of what would be a motivation for doing any research at all on human extinction if it's going to happen according to your predictions in the distant future?
Oh, okay. So I mean, so what I was suggesting is that there's some kind of chance, like that I would guess, somewhere in the ballpark of 10% chance that it's going to happen this century. So I was saying that it could be that the risk gets a lot lower than 10% if you go enough centuries in the future because we actually get our act together. But at the moment, I would think it's something like that. So that's actually pretty high. And one consequence of that view is that I therefore think that there's maybe not a 10% chance that the people in this room will be killed in some event that leads to our extinction, but it has to actually be somewhere in that ballpark, like maybe a 5% chance that, for each of us that we'll die from this. So it's actually, some of the stuff's, pretty soon. And this is not that unusual of you. It's a bit unusual, I guess, for our generation to think about this, but the people here who are a bit older than us and who lived through the Cold War, we're thinking very seriously about double-digit percentage chances of dying in a massive global catastrophe that was possibly the end of humanity. So I think we should be somewhat worried about it ourselves. But I'm actually mainly worried on a kind of ethical angle because I'm worried about other people, and even if they live in the future as well.
That may answer the other question, and we should care because it will be worse for us, as individuals.
I guess that could be right. I mean, if you've got this kind of view that where does the badness happen if there's no people around at the time, maybe the badness happens before that time because there's people at this time who make judgments about that time. I'm not really sure. No one explores these views, so I think that's because they don't work. But I don't know, I'm not very familiar with them.
Nick Baxter discussed those views.
Okay.
Nick Baxter discussed those views.
Well, this is not even quite a person-affecting one in this case, because it's kind of meta-ethical as well. So, but thanks.
Okay, I've got a long list of people now. I've got about 8 people, so when
Okay, I'll try to be quick.
and I can see some more hands. I just want to encourage you to be brief if possible, please. You by the door, you're the next.
Sure. I was curious if you'd seen any research on risks to infrastructure, so electrical infrastructure, so a large coronal mass ejection or cybersecurity risks, and if those kinds of risks are sort of at the level that you would consider to be on par with the sorts of risks you're talking about here.
So I haven't looked into either of those things in all that much detail. I know that the UK government's very worried about space weather, I think is their term for it. And I think Carrington type event is like the standard term for it, a big event which would basically wipe out a whole lot of electronic equipment for a long period of time, including generators, and which includes basically all communication systems in the UK between different settlements and things. I guess you could drive cars potentially if the cars don't have electronic starters. It's not really. I haven't looked into this. It doesn't sound very good. It sounds a lot less bad than the nuclear winter scenario to me, but I don't know the details on how long it would take to get things started again. Every now and then you get a report about this. Like there's a report saying in the US that an event like this would kill 30% of the population or something, which I thought sounded like too high. But that's just based on my intuition really, rather than, I'm not an expert in those events. They're definitely something that someone should look at.
Chris.
Thanks very much for the talk. I just wanted to ask about the natural anthropogenic extinction a little bit. So you acknowledged that there was some fuzziness in that distinction when you talked about pandemics. One thing you didn't talk about that I thought might kind of more thoroughly undermine the distinction or put pressure on it was human population. Because it seems to me that in some sense, human procreation is a natural phenomenon, and yet it's also at the heart of many of the anthropogenic risks that you mentioned. So I just wanted to ask you about that.
Yeah, I guess that's right. I mean, so population as a driver for increasing the probability of anthropogenic risks, I would kind of count on the anthropogenic side of things. So I'd be thinking, I guess, in this case, more of what are the types of events that happen, such as a nuclear war, rather than what are the risk factors that increase them, such as overpopulation potentially, or political strife, or something like that. But so I would kind of lump all of those things in on the anthropogenic side, just because overpopulation in its own isn't an extinction thing; it's the opposite. So yeah, but thanks.
My views with this is with the risk associated with AI. It seems to be stuck in the Terminator mode, whereas what we've seen is an exponential rise in the size of networks and the near ubiquity of access points to it, in watches, mobile of, in some quarters, of parts of Google having a subconscious, acting like a subconscious, not conscious. Now, if these networks become more conscious, and obviously they're going to be more compelling than they are now, and dismissing them as a technical or anthropological threat is a bit strange, because no government seems to be able to stop them. We can't stop them. No one can stop them. Now, if they do become more compelling and take more of our intelligence away from us, and the possibility that in 200 years' time we wake up one day and we don't wake up one day because we are part of some, if you like, we've evolved into insects. If that is an evolutionary step, is it considered as extinction if we become something else?
Okay, so there's a lot of things going on there. To do with the like questions about particular pathways and also the overall question. So I don't find the particular pathways very likely, or I would need to know a lot more about why you'd be worried about the consciousness and various questions there. However, I think in terms of the overall thing is like really quite interesting, which is how important, would it count as extinction if we were replaced with something else? I don't really know for the purposes of talking about extinction. I often talk about existential risk, which is defined as irrevocably losing almost all value, or a similar definition. And if you're using a definition like that, then if the things that succeed us, if they have value, like our children have value, and even if our children are smarter than us or wiser than us, they still have potentially even more value, as opposed to perhaps insects that maybe sounds a bit less plausible to have a lot of value. So that would say that it's an existential risk if we're replaced by something that is less valuable, and then you need to get into the kind of moral philosophy as to what we're talking about there. As to whether it's an extinction risk, probably is extinction if we're kind of replaced by something that isn't, we wouldn't call Homo sapiens, but maybe it would be a case of extinction without it being bad, if in the same way that we lead to new generations and we generally think that that's not so bad. So I don't know, difficult to get onto everything there, but I hope I've said enough.
Nick, it's related to that question. You just said just now that extinction would be called an extinction if we didn't have any Homo sapiens surviving us. But you also said earlier that Homo erectus became extinct. Homo erectus transformed into modern human beings. Neanderthals, on the other hand, really went extinct. It didn't quite, because 5% of their genes got passed over by crossbreeding to humans. Probably means that in this room there's equivalent to about 10 Neanderthals. I think you don't get try to put numbers as you do this. You've got a much clearer idea about what biological species, what extinction would amount. And therefore, you've kind of batted around you're using the same argument about different things, it seems to me, and it doesn't really add up. So important also in relation to the question that's raised that Martin Rees at least is arguing that, of course, the descendants of human beings will not be Homo sapiens biologically, but nonetheless they will be creatures which have been informed by our values and our intelligence and everything else, and that we ought to be proud of that rather than being frightened of it in the long run. I mean, the important thing is to make quite certain that we do have descendants which aren't like Homo sapiens, because Homo sapiens couldn't survive the death of the universe.
Okay, so again, there's quite a lot of things there, particularly that last bit, because I'm not sure that we'll be able to solve that one, even no matter what we replace ourselves with. But in terms of the question about different kind of senses of extinction, whether that's got muddled and then kind of made the argument not work or have holes in it, which we'd need to go and investigate, I don't think it does, because there are several different ways that species can go extinct. And I tried to flag this at the start. And one of them is, say, being slowly outcompeted. Another one is like basically turning into something else. So that we would say, biologists would say that species is no longer around, but now there is a new species, and that species descended from the original one. But it seems like I'm mainly interested in catastrophic extinction. And the natural extinctions are a kind of a broader category than catastrophic natural extinctions, which are a subcategory. And so since I'm mainly trying to calculate upper bounds for those things, in order to use, to compare to the the anthropogenic ones, they should still work as upper bounds. So when we look at the record, these are the kinds of numbers that you get with all forms of extinction. And so the probability per century would be even smaller if we looked at catastrophic extinction, which is what we want to then compare with catastrophic anthropogenic extinction. So I think that bit still does work.
You start with the doctor.
We obviously divide the various possibilities, as you tried to suggest, into natural versus anthropogenic. And so there's any value in perhaps integrating those two causes sometimes, because some of the examples you gave, particularly with regard to nuclear war, seem to be a combination of the two. For instance, the sun is blaring off the clouds and causes misinterpretation. More obvious examples of something that could go wrong as far as nuclear war might be something like the Chelyabinsk, a small asteroid exploded and had a force of something like 4 kilotons perhaps. Once every century or so, you might get a really big explosion. There was one in Siberia, which was equal to maybe 10 megatons. If something like that in the city during the Cold War, very easily spark a nuclear war. But obviously the cause isn't purely anthropogenic, because if you hadn't had an impact, the nuclear war which resulted as a reaction to it wouldn't have happened. So if you're making estimates about what's the likelihood of an asteroid wiping all humanity, well, it's very low. But if you have nuclear weapons,
yeah, it's an interesting case. Yeah, I certainly hadn't thought about a case just like that one there. I mean, I can certainly imagine people being a bit puzzled as to whether that was it certainly required the natural event, and it required both actually in the case you just mentioned. So, however, the reason I'm using the categories is not so much to make a kind of interesting philosophical statement about anthropogenic versus natural risks, which I think would get, your comment would hurt that if I was trying to do that. Instead, I'm trying to say, is it the kind of thing that we should be more worried about? People building, new technologies such as artificial intelligence or nuclear weapons or things like that? Or is the kind of thing we should be worried about working out how to deflect asteroids and track them and work out how to deal with supervolcanoes and things like that? Where the focus is on all the things I named are potential existential risks. Whereas it could be, for example, that occasionally you get a lightning strike, and a lightning strike at a nuclear facility, or something could lead to some false start. But lightning strikes weren't the kind of thing I was trying to put into either category in the first place. I think that what I would say there is, I guess preventing lightning strikes would have helped, but the main thing that was really needed to get the extinction to happen is the nuclear war. So I think that for what I'm trying to do, I'm okay with these categories, or at least just, even if I didn't give them names, I just told you the things in each one to let you get the feel of it. But you're right, that if one ever tries to come up with a really clear philosophical distinction between natural and anthropogenic, you're normally doomed. You just can't get it to work. So I think I kind of squeak through here because I'm not trying to put much weight on the distinction. But thanks.
Yes, thank you for your talk. I'm interested, well, I'm not quite sure whether what I'm going to say makes increases or decreases man-made risk in your view, but I'm interested in exploring the extent to which it could be interpreted the way your perspective is really a Western European perspective on life. Because what you are saying, which is not a universal idea, which is that life in general is universally valuable, as opposed to the reality, which is it's important that I survive and my children survive. And we're seeing those phenomena, of course, with ISIS and in fact, in many situations around the world, the dynamic of life, and probably historically anyway, has been driven not by this notion that you're presenting about universal counting of everybody being equal, but rather that no, I'm actually better than everyone else. And I think that's interesting, perhaps, in relationship to your story about IT impact, because obviously you weren't saying that all life is extinguished by the rise of IT, sort of AR intelligence, at least in hints of that. And so that would suggest that, in fact, as far as a certain type of lifestyle, that the AI growth has no relevance. So presumably daffodils have no interest in whether AI does or doesn't grow, and so there might well be peoples around the world would regard it as a great victory for survival, but that the AI impact destroyed civilizations that are negative and bad, back to that point about moral civilization. So in fact they might be destroying all the bad in the world and leaving us with the good in the world. And the good, of course, is what we have all for millennia been focused on increasing and driving. So in fact the net might be, maybe in the perspective, that we're improving the world with these things rather than
Okay, so I think the only bit of my talk that technically really talked about this was the bit where I said, the first line, I think, where I said that it's pretty much the worst thing that could happen. Everything else was really actually just trying to quantify how likely it is, rather than saying whether it was good or bad. It would kind of take it as tacit that most people think it's bad. And you're right that not everyone has a kind of universal view that everyone's equally valuable, or even if they say that everyone's equally valuable, they don't act as if that's quite the case. There are also some potentially people who think that other groups have negative value. I think they're probably generally wrong about that. So there are definitely people out there who have views that are just bad views, and I'm not going to worry so much about whether I would be taken as being correct by them. But it sounded like it was actually getting into some stuff that the first couple of questions were about, to do with what if you just had just got rid of these humans and just went back to having daffodils and trees and things like that, and some rhinoceroses and things. Would that be better?
Well, I would just be careful saying that, but more that there are small pockets of people who, like in many moments in our history, have viewed the destruction of other people as a good thing.
Yeah, I mean, I guess that fits in with my point about Elm Shinriko and other groups where I said who would be nasty enough to actually want to do the engineered pathogens. There are some people who would, and
remember though, we are the product of that. So we're the result of those victors who have destroyed many others, including these people who spoke about that.
I think we might move on, because I think we have time for 2 more questions.
Very briefly, just on this in the first question, just an invitation to say, I heard this right, that at some point in the talk you seem to say something like probably Homo sapiens wasn't a good thing on the whole so far for the planet or something. I just a little bit more about your background.
Yeah, sorry, it's a little bit glib. What I was trying to say was that there's no doubting that these days that Homo sapiens is actually having a very, if not the dominant species. Some people argue that various forms of bacteria would be dominant species. It's quite a good argument on that grounds. But it's at least a dominant species that's clearly having massive impacts of various forms. Moving more kind of minerals around than any other species, doing at all kinds of levels, having huge effects on the world. So all I was really trying to say was that we're able to have this remarkable kind of position because of our intelligence, and using that as an argument that if we therefore were to create something that had even more of this intelligence than us, that the one way in which we're unique, which turns out to be the one way in which we're able to have so much control about the world, would no longer make it be unique in that way, which to show that there's natural reason to think that we could be in a bit of trouble at that point. I don't really know about what I think about humanity's effects so far. We've certainly done a lot of bad stuff. I think that a lot of our lives though have been worth living, so that's been good. I definitely am very positive though about humanity for the future. I think that there's been a huge amount of moral progress over time, and I think that will continue, and I think we'll be able to do a lot of good things in the future. So it was more that I don't rely upon claims that we've done good things in the past in order to get the claims that I want.
Okay, now I think we'll make this the last question.
I just would like to know how we can balance progress and existential risk, because how can we ensure that the scientists are going to work on the HIV treatment and not the terrible virus we talked about?
Yeah, it's a good question. Okay, so yeah. I don't know. This is something, I think that if humanity was serious about this stuff, I think that we would want to make avoiding existential risk kind of iron commitment, that we were not going to break. So we would do a lot of other things within that framework. If it's the case that we thought that we could cure HIV 1 year earlier, but that would have an appreciable impact on not having any future generations at all, and having everyone in this generation be killed, that would be a pretty bad idea. So I think that in a lot of cases we'd want to go quite a bit slower than we're going at the moment, and we might want to develop better systems for regulating such research. That's not to say that we should look at our current regulatory tools and just slap on a whole lot of them on this research. That might be a bad move. But we need to think more seriously about how to get various forms of good regulation to work, including self-regulation and so on, with some of these things. Ideally, a lot of the people in these scientific and technological fields will take this stuff seriously. In AI, there's good news on that. It seems that people at the forefront of this are actually taking these risks very seriously now. Some of the people at the forefront, taking it extremely seriously and trying to be very careful. So I think that there's, some hope for optimism there. But I think that if it were the case that all centuries were going to have the kind of risk profile of the 21st century, or even the 20th century, then we're not going to be getting many more centuries in expectation. I think that we need to bring that number down, the risk per century, and I think that we'll be able to do that. But not with 100% probability.
Okay, I'm afraid we're out of time. Apologies to the people who didn't get to ask their question. But please, all of you, do feel very welcome to join us for a drink over a crash in the Alison Richards building just to the north of here. But before we do that, please join me in thanking Toby for the really